Hey guys, welcome to question MM392 of the Maths Methods Fortify study guide. So in this question, we're asked, or we're told, the height of any given tree in a particular forest area is given by x meters, where x is a normally distributed random variable with mean 8.4 meters and standard deviation k meters. A sample of 300 trees is researched, and 11 of these trees are shorter than 7.3 meters tall. The value of k is. Alright, awesome. So as soon as we see the fact that we don't know our standard deviation, or if we don't know our mean as well, what we're going to have to do is use our inverse normal to find the z value at the point that we're dealing with. So what I mean by that is, if we draw a normal distribution graph, we know that our mean is 8.4, right? But we don't know how much our standard deviation is. That's what we're trying to figure out. We're trying to figure out how far away from the mean our standard deviations are. So this is our x value, and each x value has a corresponding z value, right? Which is how many standard deviations away from the mean we are. So we have a 7.3 meters. So let's say 7.3 is somewhere here. And we know that 11 out of the 300 are shorter than this, right? So 11 out of the 300 lie in this area of the graph, right? So 11 out of the 300. Which means that the probability of any one of these trees being less than 7.3 meters is 11 on 300. And that also means that the area of this is 11 on 300, right? So probability is equal to area in normal distribution. So, knowing that, what we can actually do is use our inverse normal, which we use when we know our area or we know our probability, but we don't know our x, or we don't know our z value, right? So inverse normal, we use to find our z-score, or our z value, or our number of standard deviations away from the mean, all the same thing, right? So inverse normal is going to ask you for three things: area, mean, standard deviation. So our area is our probability, which is 11 on 300. Now with inverse normal, we always need to take the area, or the probability, to the left of the value that we're thinking of, right? And it's told us that 11 are shorter than 7.3 meters, which means we can just use our 11 on 300. Our mean for our z value, because remember we're dealing with our z values here, we want the z value, and you'll see why we do this in a second. We could normally say that our mean was 8.4 and our standard deviation is whatever, right? But we don't know what the standard deviation is here. So we need to use our standard normal distribution, which is mean of 0 and a standard deviation of 1. And what this gives us is a z value of negative 1.7908. So what that means is, at this 7.3, we are 1.7908 standard deviations less than the mean. Okay, so that's what this means. So z, we also know, is equal to x minus mu over standard deviation, and this is your magic formula for this section, right? So we know that our z is negative 1.7908. We know that our x value is 7.3. So the x is the actual length of the trees or whatever, or the wingspan or whatever it is you're dealing with. And the z value is the standard deviations away from the mean that that value corresponds to, right? So 7.3 minus our mu, which is our 8.4, divided by our standard deviation, which is k. And we're trying to find k, right? K, this is the whole point of this question, to find k. So rearranging all this, we get k is equal to 0.6143, which is 0.61. And that is our answer of C. So C is our answer for MM392, guys. If you have any questions about that, I know this is a weird process, but as soon as you don't have one of these, inverse normal is your friend to find your z value, and then you can use this formula here. So, as always, ask me any questions you've got. Otherwise, thank you for watching, and I will see you in the next video.